Next up, let's learn about variables. A variable is a storage compartment for data. Once we give this compartment a meaningful name, the rest of the flow can directly use that name to access the stored data. In our earlier explanation, we've actually already come across the concept of variables. For example, when we use open web page to get a web page object and name it Automa site, this command actually creates a web page object variable for us to store the web page. The variable name is Automa site, and the variable value is that web page. It's the same with elements. These variables are created automatically when you use a command, and for later use, you just need to look them up by name. For example, when using click element, set the web page object to Automa site and find the element we named Automa main book demo earlier. Then you can click the Book a Demo button on the official website. You can use set variable to set the value of a new or existing variable. Next up, you just need to master 3 core data types: string, number, and list. Variables of the string type store all textual information such as names and addresses. The creation method is very simple. In set variable, the variable type defaults to string, then just fill in variable value. There are 2 input methods. The first one is text mode. Input is treated as text by default. If you set the input variable value to Automa and name the output variable name, then the variable name represents Automa. Later in the flow, if you need Automa, you can reference it directly via name. For example, use print to print it, and the output will be welcome to Automa. The other one is expression mode, which needs to follow Python syntax. This term might sound a bit unfamiliar to you. Python is a general-purpose programming language. Of course, you don't need to master it fully. You just need to remember what I go over in the course. In Python, the standard way to write strings is to put the content in single or double quotes. Copy a set of commands, turn on the Python icon here, and re-enter Automa with quotes on both sides. Similarly, print needs to switch to expression mode too. But what should we write here? First off, think, what type of data is welcome to? That's right. It's also a string and needs to be wrapped in quotes. Also, if we want to print welcome to Automa in full, we need to concatenate welcome to with the name variable we defined earlier. How do you concatenate strings in Python? Just use plus between the 2 strings? All right, now the method is clear. Let's just go for it. Run it again, and it prints successfully. On top of that, the standard commands also include some commands for handling text data. If you're interested, you can head to the corresponding command set to check them out. We've already got the hang of strings, so how do numbers work? As we know, number types include integers and decimals, and they support calculations and comparisons. In Automa, switch the type to int for integers. The icon here is already turned on, and we've got expression mode enabled. At this point, enter 2 and rename it to num_a, which assigns the integer 2 to num_a. If you want to define a decimal, you can also switch the type to float. Enter 1.8 and rename it to num_b. This variable then stores the decimal 1.8. Now, I want to print the sum of num_a and num_b. How do I do that? It's super simple. Use a print. Turn on expression mode, then in fx select num_a and num_b and add plus between the 2 variables. Run it, and the total sum gets calculated successfully. Suppose when you create num_a and num_b, you don't turn on expression mode. What happens when you add them? Let's give it a try. Copy these commands, turn off the expression mode in the set variable, run the whole thing, and the result's totally different. Obviously, when expression mode is on, you'll get the total sum. When it's off, adding them just does string concatenation. So numeric variables have to have expression mode turned on. In practice for convenience, Automa also supports doing calculations with numbers in text mode. But to avoid unexpected results, we recommend keeping variable definition and usage in the same mode as much as possible. Like if you had expression mode on when defining, try to keep using that mode afterward. A list stores an ordered set of data, like a train where each carriage holds one piece of data. For example, when we go shopping, we usually make a shopping list that has all the items we need to buy. This shopping list is a real-life example of how lists work. At this point, you might be wondering, why use a list for a shopping list instead of a string? To answer that, we first need to clarify the key differences between lists and strings. A string is basically one continuous block of text, and you can't split up the data inside it. For example, with the string, Automa can't directly recognize that apple and milk are separate pieces of data, so it's even harder to find one of them. But a list is different. It clearly tells Automa this is a group of independent data with clear boundaries. How does this work? Let's create a new list first. Defining and using lists in Automa also requires expression mode. The standard syntax is to wrap all content in square brackets, with data items separated by commas. Pick the type as list, and the system will automatically turn on expression mode and create a pair of square brackets. If you use a list to represent the shopping list we talked about earlier, enter this using the standard syntax. Each item is a string, so it needs to be wrapped in quotes individually. Rename it to list. Next, we use print to print the data in the list. Since we added a separator between each item, the data in the list has a positional order. You can access any item using its index. But there's an important note. List counting starts at 0. So list 0 inches accesses the first item in the list, apple. Additionally, Automa offers plenty of standard commands for working with lists, including adding, deleting, modifying, querying, reversing, sorting, and more. If you want to learn more about these features, you can check out Automa's official documentation. In fact, you can freely convert between the three types we mentioned earlier. We'll cover how to do that in later lessons. Finally, keep this in mind, whether it's object, element, or other types of variables. Names should be clear and intuitive so you can tell what they represent just by looking at them. Don't use duplicate names, as this can cause overwriting. With standardized naming, referencing and identifying variables later will be much easier.